So today, our first lesson, we're going to talk about multiplying and dividing fractions. Now, I know that you've multiplied and divided fractions for years and years and years, but we really want to just make sure that you don't have any blank spots in your skills areas. And we're going to focus a lot today on how you know from a given situation whether you should multiply or divide. Okay? But we're also going to go through and reinforce the skill as well, right? So we're going to talk about the steps of multiplying and dividing fractions. Then we're going to move forward with that and talk about how you know when you should multiply or divide, because frequently students want to always divide fractions for some reason. So the first thing we want to do is, and again, you're going to be using that split page note system, so I'm going to as well. All right, is when you're talking about multiplying or dividing fractions, always think for any problem that you work with, there's one question that goes with everything that we do. Always think about what operation you're being asked to do. Now, that's not going to be one of the steps for solving anything, but it should be question one for everything. Because if you don't know what operation you're working with, then you're not going to be thinking about what steps you should use to do that process, right? Because is multiplying fractions the same as adding fractions? Absolutely, miles apart, right? So what operation you have is going to be really critical to being able to work them. You also need to always think of what kind of, and I'm going to say numbers, although I won't anymore after this. In a bit, we'll talk about that. So what kind of numbers you're dealing with. Because multiplying 2 and 3 is vastly different than multiplying 2/3 and 4/5, right? So you need to always think about the numbers that you're working with. Okay? Now, in order to multiply or divide fractions, we need to talk a little bit about another operation that should be first and foremost in your mind anytime you see any fraction. We need to talk about the idea of simplify or reduce. Again, this is something that you've done a lot, and I put both words down because some of you may have learned it using one or the other, or maybe even some other term. Okay? What we need to remember with fractions is that a fraction is not really a number, right? If you have some A over B, what that literally means is A divided by B. The fraction bar is just another way of writing the division symbol. It's a lot easier to write as a fraction. Actually, the fraction came first, because if you look at the division symbol, right, 2 dots with a bar, that's a fraction, isn't it? So that's where that came from. But the fraction bar is the original way of writing division and the most efficient way. When you're moving and working in algebra and you go into more complex mathematics, you will always write division using the fraction bar, right? But in this particular case, it's how we derive fractions. And so if it means divide, then that's where we should always begin. And that's what simplify or reduce means. It simply means divide away, not cancel. That's one of my favorite words to hate. Cancel implies that everything goes away. Now, they don't really go away. If you divide something by itself, what number do you get, guys? A 1, right? And a 1 is a number, right? It's not a nothing. So cancel. All right. Divide away any factor. A factor just means anything that will divide evenly into something else, right? Remember that word, factor? So it means just something that will divide evenly. Any factor that is common to both numerator. What's the numerator mean? That's the top number in a fraction. Good. And the denominator, which simply means the bottom number of the fraction, right? Numerator, denominator. So, for example, 4 over 12. That's a fraction. You can tell because of the fraction bar. What number will divide evenly into both 4 and 12, if anything? 4. Yeah? Okay? Yeah, just sing out. So I'm going to divide them both by 4. 4 divided by 4 is going to give you what? And 12 divided by 4 is going to give you what? So the simplified or reduced version of this fraction is 1/3. Yeah? Been doing that since you learned about fractions, right? Important skill. Make sure you do it. Your fraction is not correct. Your answer is not correct if your answer is not reduced or simplified. Okay? You must always do this. And the reason we start with that is it is the most basic idea of fractions. Now, do all fractions reduce? Anything common to 3 and 5 at the same time? Nope. So not all fractions will reduce, right? But you need to always see if they will. First of all, it makes your life easier. Would you rather work with 1 and 3 or 4 and 12? Right? Most of us are more comfortable with smaller numbers, and it just makes your life easier. And if you don't simplify when you're working with the more complex algebraic fractions, which we'll get to, then you can't do the work. It just simply won't work. So you need to get in the habit of simplifying. Make sure you always simplify. Okay? Now, we're talking about multiplying or dividing, but again, we need to have that little bit of background. Because in order to multiply and divide, sorry, I know I write this down. I should have done the simplify first, sorry. To multiply or divide fractions. And again, don't cheat yourself and do shorthand tricks. To multiply and divide is not what we're doing. We're multiplying and dividing with what? Fractions. Say it all. It helps to trigger your mind and then make yourself stop and think about what it is you're doing. Because you can't possibly hear the word yellow. What just happened in your mind? Did you see the color? Did you see something that is yellow? You can't avoid it. Now, it might have been fleeting. It might not have been something that's really you focused on. But I don't care who you are. You thought or saw something yellow when I said the name. Well, you can use that trick of the mind to be able to do mathematics better. If I say fraction, you can't not think of what? Some rule, some idea of what a fraction is, or something you've done or hate. So something is going to come up associated with a fraction. So we associate words. Your mind wants to make those connections and associations on its own. So use the way your mind works. So say the words or think the words and things about it. The first step to multiply and divide fractions is to simplify. Now this may be different than the way you've been doing it in the past, but remember that my job is to clean it up. You've learned processes in the past, but my job now is to get you ready to go beyond just being able to do the math, but to be able to do it efficiently and to be able to do it with more complex ideas. All right? So if you don't simplify and you're multiplying 2/3 times 6/7, for example, if you just multiply straight across and then simplify after you multiply or divide, that works if the numbers are small. But when you start working with algebraic expressions, algebraic fractions, it stops working. Right? So, do you want a rule that works sometimes, or do you want a rule that works always? Yeah, you bet. So, think of that. I'll always explain why I'm telling you to do something differently than you've been taught in the past, right? Now, simplifying first does mean it makes it a little more complicated because you have to do the division first, right? Which is why we don't teach it in junior school, and most middle school students don't simplify first. They simplify afterwards, right? Because it's easier to concentrate on the multiplication and then do the simplification at the end for most students. It's just an easier process, but you've got to grow up. Now, most of you probably learned this, I don't know. Do you simplify first normally when you multiply or divide? Or just multiply straight across and then simplify the answer? Yeah, and that's a teaching tool. And it makes sense for when you're doing it, but it's time to let that go, right? You got the nice white collars now, so you got new responsibilities. So you got to be thinking about things, thinking about the future and where you're looking for. So you're going to simplify first. But if I'm multiplying or dividing with fractions, that means I'm going to have more than one fraction, right? Otherwise, you don't have multiply and divide if you only have one fraction. So you're going to have two fractions. So we got to think about, we have two numerators and two denominators. So when you're simplifying, we can simplify any numerator to any denominator. Okay? Actually, scratch divide off of there, I'm sorry. No, I shouldn't, since I'm working with the actual rules now, I should have just, the rules for multiply and divide are slightly different. So we're talking about multiplication first. Sorry, I shouldn't have written that down. So simplifying, any numerator to any denominator. As long as you're crossing that fraction bar and the operation is multiplication, then you can divide away the common factors. Okay? And the easiest way to show that is by just showing you what you normally do. So 2/3, and another thing that you're going to see, I always, as my multiplication symbol is a dot. You don't have to use it, but that's what I use as a multiplication symbol, because an X, unless you write it, y'all are used to writing them differently, and I get that. Don't change if you don't want to, but recognize if I write a dot, I mean what operation? Multiplication. Okay? Can we agree that works for y'all? If it's going to freak you out, sorry. I'm not going to change. All right, so 6/7. Just simple, right? If you multiplied across like you normally did, it would be 2 times 6 over 3 times 7. So you see that you're going to put those things together anyway, right? Yeah? So what we're going to do, though, is instead of doing that first, we're going to simplify. And since the numerators are all going to be in one fraction and the denominators in the same fraction, we can simplify any numerator to any denominator. It doesn't matter which fraction it comes from. So let's look at the first one. Is there anything that will divide evenly into 2 and 3? No. Is there anything that divides evenly into 6 and 7? No. But we could also go diagonally. As long as you're crossing that fraction bar, going from the top to the bottom, we can do that. So is there anything common to 2 and 7? No. But what's common to 3 and 6? They'll both divide by 3, right? Okay. Now, 2 and 6 in the top both would divide by 2. But I'm not crossing the fraction bar, so I'm not allowed to do any division, right? You have to be crossing the fraction bar using that division symbol to be able to do it. So I can't do anything with the 2 and the 6, but 6 and 3 will both divide by 3. So the 6 will become a what? 2. And 3 divided by itself is a 1. So that's what I mean by simplifying. Okay? So simplify any numerator to any denominator. And now we're going to be working with much smaller numbers first, which is nice. And the second thing is, once you do your multiplication, your answer is finished. It will never simplify any further as long as you simplify first completely, right? So it's done. Then our second step is simply to multiply across. Numerator times numerator, denominator times denominator. Okay? Now that says multiply across, not cross multiply. There's no such thing. I will talk to you about that in a minute, and it makes me crazy. All right, so I have a lot of things that make me crazy, sorry. So in the top, I now have 2 times 2, which is going to give me what? 4. And in the bottom, I have 1 times 7, which is 7. Okay? And is there anything common to 4 and 7? Nope. And I knew there wouldn't be because we simplified before we multiplied. Okay? So you've done the process, but you've probably multiplied across and then simplified it. My thing for you now is that you should simplify when? First, and then do the multiplication. And again, you're not going to see why right now, because it literally doesn't make the difference in your answer when you're doing just numbers. But when you get to the algebra, it makes a huge difference. You'll build some creation that you can't fix if you don't simplify first in the algebra sections, right? And you're going to be doing the algebra sections. So, right? I'm just trying to get you into good habits so you can move forward. So that's multiplying fractions. Yeah? Well, let's talk about dividing fractions. So that's all there is to it. 2 steps, right? Simplify any numerator to any what? Denominator. And then just multiply how? Straight across. No big deal. All right. Now, to divide fractions. The thing you need to know about dividing fractions is that you can't. You can't divide one division problem by another division problem. It simply doesn't work. But we can create a situation in which we can do the work, right? And you're familiar with this. So, you can't divide. And the reason I want to stress that so much is because that way you'll see the division and think, oh, wait a minute, this is a weird situation, right? Okay, it's different. You can't really divide a fraction. But what you will do is, okay, so you can't divide. Instead, you multiply by the reciprocal. Again, this is not the steps. I'm just explaining what it is you're going to be doing, right? And giving you the ideas that you're going to need. So, multiply by the reciprocal. Have you heard that word before? Reciprocal? Okay. Well, reciprocal, you're going to hear it. I'm going to speak in math terms because from this point forward in your career, you're going to be given things in the real language, right? A reciprocal simply means that you take the fraction a over b and turn it over and it's b over a. So you've done it before, even if you haven't used the fancy word for it, okay? So, and what happens with a reciprocal is if you multiply 2 reciprocals together, you're going to get a 1. It's all going to simplify away, give you a 1. Right? So in effect, we're multiplying by 1, which we're allowed to do at any time. So the reciprocal of a over b, it's a terrible a over b is b over a. You simply invert it. You may have learned this as invert and multiply, or I don't know, what phrase do y'all use here? Got to be some catchy little phrase to, no? Oh, well, okay. All right, so the reciprocal of anything is just a over b. So let's just do a few examples of the reciprocal. So I want you to find the reciprocal, or just tell me what the reciprocal is. Ooh, I can't spell it. Reciprocal of these things. So 2 over 3. What's its reciprocal? There you go. Could be any easier, right? No math at all. How about this one? Reciprocal of 7.
1/7.
You betcha. Okay? Remember that every number is a fraction. If you have a whole number, or a number that doesn't look like a fraction, it really is a fraction. It simply means its denominator is 1, and dividing by 1 doesn't make any sense because you get right back where you started from, so we don't bother to write it, right? So every single number you ever see is a fraction. But if you don't see it written as a fraction, that means the denominator is a 1. So when you get the reciprocal of it, it's just 1 over 7. You're going to use that a lot today, okay? So you're going to have a lot of time when you're working with numbers, with whole numbers, and turning it into fractions and finding the reciprocals, okay? So to find the reciprocal, you just flip it over. What if it's not a fraction? It's just 1 over that number, right? Okay? So now let's talk about the steps for multiplying. I'm sorry, for dividing. To divide. First, okay? The first fraction never changes. Do not take the reciprocal of the first fraction or the reciprocal of both of them. The first one never changes. It just stays the same fraction. Division becomes multiplication. Okay? Oops, sorry. Don't write that down if you're already there with me. Okay? take the reciprocal of the second fraction. In which case you no longer have a division problem, so follow multiply fractions rule. So what you're doing is turning something that you can't do into something that you can do. So the first fraction never changes. The division symbol becomes a multiplication, right? However you write it. And then you're going to take the reciprocal of the second fraction, which simply means flip it over, right? Which means you no longer have division but multiplication, so you simply follow the rules for multiplication, and which we just learned. What's the first rule for multiplying fractions? Simplify. Thank you. And what's the second one? Multiply straight across. Okay? But don't forget to simplify first. Okay? Get in that habit. All right. Let's just look at an example really quickly. Say we have 2/3. I don't know why I'm on a 2/3 kick. Don't worry about it. And it's 9 over 12. Right? Now, I've purposely picked these numbers because you see a fraction, your first instinct is to simplify these. If you started simplifying across, that's not the first step. There's a symbol here that says what operation you're dealing with, right? And that operation means everything. So always identify the operation first. What operation are we working with here? Divide. With what kind of numbers? Fractions. And what do you know about dividing fractions? You can't, right? So we need to change it instead to something we can do. And what we can do is multiply by the, what's it called? Reciprocal. So will the first fraction change? 2/3? No. First fraction never changes. The division becomes what operation? Multiplication. However you write it, it's fine with me. And 9 over 12 is going to become what? Okay? Now we're multiplying fractions. So before we multiply with a fraction, we always simplify. And this one, I can give you a little funny one here because I've got 12 over 9. What do you know? 12 and 9 will both divide by what? 3. So you can still simplify individual fractions too. And so divide 12 by 3 is going to give you a 4. 9 divided by 3 is going to give you a 3. Then see if there's anything that'll divide diagonally across. But in this case, because we simplified that first, no, there's not. Now, if you had done 2 and... we can do 2 and 9. But you could do 3 and 12. You could have simplified across instead. Or sometimes you end up with something like this. So you end up with like a 15 and 3, so it will simplify a second time. So always still look. Even if you simplify one fraction, make sure you see if it'll still simplify diagonally. Okay? All right. But in this case, that's a 4. So then I'm just going to multiply how? Straight across, I get over 8 over 9. Yeah? All right. So hopefully this is not news to you. The simplifying first thing maybe, but otherwise multiplying or dividing fractions shouldn't be new, right? A couple of new words and doing the process in a slightly different order, but otherwise you're good, yeah? Okay? Now, so I'm going to go over always, now maybe not in this much detail, but always, any operation that I need you to do, we'll always look over it, right? And this is the part where I'm telling you might be a little bored because it's stuff you've seen before. Deal with it, okay? Because now what we need to do is we need to talk about why it is we're looking at this and then talk about the pieces. And then we're going to go through some examples of all of it all mixed together for you guys, okay? So what we need, our next topic here is, how do I know when to multiply and when to divide fractions? So you're going to be given a scenario. You get a chocolate bar, you got to divide it into 3 pieces or something like that, but obviously it's going to be with fractions. So you're going to be given a scenario, and you have to decide, do I need to multiply by the fraction, or do I need to divide by the fraction? Okay? And that's what we're going to focus on. And most of the time, the rules that I'm going to show you will apply. There can be exceptions, but in the work that I'm going to give you today, and and as a general rule, now there are exceptions to everything, right? So, as a general rule, what I'm about to tell you will work every time, and we will get familiar enough with it if we see a special case situation that we can identify it. Okay? There are key words for every operation, right? So if you hear the word sum, what operation is associated with a sum? Anybody remember? Addition, right. The answer when you add is a sum, right? So if I tell you to take the sum of 2 numbers, you know that means you need to add them. And we'll talk about those as we go to. We'll talk a little order of operations later. But there's a key word that we use all the time that means to multiply, but most students think it means to divide, because it's associated with fractions, which are division problems. And that's the word of. If you see the word of, you should always think multiply. Okay? So, for example, if I say 2/3 of the cars in the parking lot are red, then there are 12 cars in the parking lot, then it would be 2/3 times 12 to tell you how many of those were red. So, do you still instinctively want to divide when it's of? Yes, most people do, but don't. The word of means what operation? Multiply. Okay? And we'll go through several examples of this as we go. So if you see the word of, think multiply. 3/4 of the students in this classroom will get excellence. Okay? And all of you all. Okay. I've got high expectations, right? So of means multiply. Take the fraction times whatever the total is. Right? Now, be careful though, because you might have a problem where you're dealing with division, but it's fractions, you'll see the word of in it, but it doesn't mean to multiply, because the of is not associated with the number that you're dealing with. Okay? So, 3/4 of the students. That of the students means what operation? Multiply. Okay? 3/4 of the students also take history, and you're given the number of people who take history. Is that word history connected to that of? No, that phrase is way ahead of that, right? That does not mean multiply. That's when you know that you're going to be working with division. Okay? So if the word you're dealing, and we're going to look at lots of examples, so if you're confused by that, don't panic. So if you have the word of associated to the thing that you're given the number of, then you know it's multiply. Otherwise, it's going to be what? Division, right? You only get 2 choices here. Okay? All right. So the easiest way to recognize when to divide is to know that you're not supposed to multiply. Right? So we're going to look at lots of phrases and pull those out. That's where we're going to spend most of our time today. Okay? So let me pause this for a moment. All right. So we knew the word of meant what operation? Multiply. So we took our fraction times the number of chocolate bars. We simplified, multiplied straight across, and make sure that you put your units. And in this case, our units were chocolate bars, or bars of chocolate. Okay? Look pretty good? Really doesn't get much harder than that. Let's see. Just clicking through. Ariana has a chocolate cake that is cut into 12 equal slices. Her family each gets 1/2 of the cake. Okay? 1/2 of the what? And what do you know about the cake? That it's 12 slices, right? Now, because they can't each individually get, there can't be more than 2 of them if they're going to get half each, right? And nobody's going to give you half a cake. So it's really not half of the cake, but half of the 12 slices, right? So that's what we're trying to find. If they're going to get half of the 12 slices. Now, this one's easy. You don't have to do any math, but we're going to anyway. So it's 1/2 times the number of slices. Put it over 1. They'll both divide by 2. And, of course, that means you get 6. How much? There you go. Now, 1 a unit. Not 6 cakes. 6 slices. All right? But our key here was of the cake slice, but the cake was sliced, right? So you do have to use a little common sense sometimes. Okay? All right. I should have marked down here when division problem. Of the target is 90. Of the target, so what operation? Multiply. Okay? Painting his new house, he uses here's a good one. 1/6 of his paint to paint 5 walls. You've got an of in there, right? But what word is the of associated with? Paint. But the number that you know is not paint, but what? So therefore, the number that you know is not associated with the word of, so you're not going to use multiplication here, but what? Pretty straightforward. Keep stopping. My recording keeps stopping, so this one's going to be a really bad recording. I could do 3/7 of, how many seats? 420. And of those, 1/10 of them are going to be leather. Right? And you don't even need the brackets, parentheses in my world. Okay. All right. So, can you tell the word difference between multiply and divide when you're having given an applied problem? That's your focus of this lesson. Okay. All right. Again,